Hello everyone, welcome to a new tutorial series in which we take a look at the OpenCV and Deep Learning for Java libraries, and we try to use them to solve a Sudoku puzzle. Actually, we do not try it, we already did it, or I did it, and I will be guiding you through the process in this tutorial series. So it will be a short one, I'm not sure, a couple of videos where I'm going to explain all of the steps I took to be able to take this image here and recognize the digits on it, solve it, and print out the result. So let's just get directly into it. So this will be a Java project. I will be using Java with OpenCV, and I'm also using Intellij as my IDE. So if you want to follow up with that, you could just install it and use the same things as I do. For our library or dependency management, I'm using Gradle. If you do not want to use Gradle, if you want to use something like Maven, for example, not much will change for you. So you just have to import the dependencies a bit differently, but the rest is exactly the same. So let's get into it. Currently what I have here is these couple of folders, which we are not going to be taking a look in this video. So we'll take a look at them in the next one. But for now, we are going to take a look at this image. So whatever is named Sudoku is the one that's going to be loaded by our application. So we have Sudoku 1, which is just there, so we can try it out later on. But for now, we are loading this in. So what we want to do is we want to load this image. We want to recognize all of the digits. We want to recognize where we have empty spaces. And then we want to solve this puzzle. And let's see how we do that. So let's go to our application. And here, maybe I can make it a bit bigger in case you don't see it. We have a Sudoku solver class where we are doing all of the solving. But let's take a look at our build Gradle file. Let me make this a bit bigger also. And let's see what kind of dependencies that we have here. Here you can see that we have a dependency for the OpenCV, of course. So this is the version that I'm using. And we also have the dependency for Deep Learning for Java. So we have a couple of dependencies here that we need. And the version that we are using is this one here. So that's everything that you need to load. So if you don't know it, once you add dependencies to the build Gradle file, you have a Gradle tab here and you can just reload all of the Gradle projects and you will have them. Okay, now let's close this one and go to our Sudoku solver class. Here what we have is in our main method, we do all of the magic. So what you have here, let's just go directly through it. Let's go through all of the steps and see what we do. We have loading of the OpenCV. So this is an OpenCV method to get it set up. Then we also load our trained network. You, of course, when you start this project, you will not have this trained network immediately. You will have to load, you will have to train it, or you could actually use mine. I will publish all of this code to GitHub, so you can just use it there. But I will also be explaining how you can train your own, but in one of the next videos. So for now, just keep in mind that we have a network that's already trained and is able to recognize digits. So here we are using a util class that we created, and we load the network. The next is the OpenCV things that we do with our image. The first thing that we want to do is we want to load the image with the name Sudoku. And with that, we want to do some processing on it. After the processing has been done, we also do the loading of the same image once more. This is just used for debugging. Later on, we'll take a look at the debugging image and see what we are actually doing on it. Then what we want to do is we want to mark the outer rectangle and the corners on this debugging image. So it's just for us so that we can see what exactly we are doing. And then we want to go to our processed image. The processing that we did is basically we changed it to the gray image, and we also inverted some bits, and we tried to make it easier for OpenCV to see those digits, but we also want to remove the lines. So the lines are these ones here. So if I open up this image, you can see the lines here and in between all of these cells. We want to remove them on that image, and so that it's really clear where the digits are. And after we have done that, we use our util class, which we'll also take a look, to get the Sudoku matrix out of it. So what we do is we take this image and we create a matrix 9 by 9, and we load in the digits that we can find. So our first row would be 5, 3, and then we would load 0, 0, 7, 0, 0, 0, and so on. So wherever there is an empty space, we just load a 0. And with that, we use the Sudoku util to solve the Sudoku matrix. The Sudoku util, I will not be going through it, so this is not my code. I did not write this because I just wanted to save a bit time. So I copied pasted it from this link. So please do check out their page. They have a really nice description about it and explanation how it's being done. So I will not go through this. If you're interested, you can find it here on this link, and you can take a look at the things that they did and how they did it and why they did it like that. After we have solved our matrix, we print it out to the console, and we also print it out to the image. And if we are not able to solve it, we print out a message why we are not able to solve it, and we save these processed images and debugging one. So let's actually just run this. So if I go here and run it, we are going to see all of the steps that we are doing. And then I will just guide you through it and see what we do. So you can see here that we are doing something with this deep learning for Java library, because we are loading the trained network and we are actually initializing all of the things that's needed for them, for it. And here you can see our solved matrix. So if we compare it with the image that we have, you can see we have 5, 3, and then there were 2 empty spaces and a 7. Here you can see that we have 5, 3, and then those two empty spaces are 4 and 6. 7 is there. So for those of you who do not know Sudoku, you cannot repeat numbers in a row and in a column. So for example, 5 should not be repeated anywhere here, and 5 should not be repeated anywhere here, and also 5 should not be repeated in this small 3 by 3 square. As you can see, that's being done already, so it works really nice. And if we go back here, you can see that we have saved some images now, and we can actually take a look at what we do. So this is our original image, the one that we started with. This is the first processing that we did. In this case, it doesn't really make a big difference, but you can see here that we have printed out some corners on it, and we have basically cropped it a bit. So we are just shrinking it a bit. Then what we did is we inverted it. We said whatever is black, make it white, whatever was white, make it black, and that's something that's done here. And then we discovered all of the lines and removed them. So this so that it means that we only have the digits left. And I also saved the digits, so you can see them here. We actually cut them out and save them. You can see that they are in the same order as they are presented here. So 5, 3 and some empty spaces, and then 7, then 6, 1, 9, 5, and so on. And here you can see in the debugging, you can see actually the solved one. You can see that the outer rectangle that we printed, and also the points. I will be showing you how we do that. And you can see that we also filled out the solution here. So it's the same matrix as we filled in the console. It's exactly the same here. Okay, so basically it's done, it's solved. But now let's take a look at the code and see step by step how we do it and how we get to this final solution. So let's take a look at the pre-processing. In the pre-processing image, so we are passing in just the loaded image, so the beginner image, so the beginning one, and from it we create a new one. It's just an empty one. Let me remove this space, and it has the same height, width, and it has some type. And what we do first is we turn it to a gray image, and we also save it. So it's 1 minus 1. If we go back here, it's this one. It doesn't really do much here. We could actually maybe even get rid of that step, but for now let's just leave it, because it's not, there are no colors, it's already black and white, so it's, yeah, it doesn't really make sense in this case. But if you would have a colored image, you would definitely want to do that. Then what we do is we invert it as I showed it here, and we save it into 1, 2. So here is the inverted one. Whatever was white is now black, and whatever was black is now white. This is just for us to easier recognize some of the things later on. All of these methods are coming from the OpenCV library, so if you want to take a look at a closer look at them, you can definitely check it out on their page, and they will explain you what we did exactly. So what those methods do. Now let's go back to the Sudoku solver, and we have the processed image now, and we also loaded in the debugging image. So it's nothing special, we just load it in. Now what we want to do is we want to mark the outer rectangle and the corners. So this is, if you take a look at this one, so this green outline is what we want to do, and we also want to do these blue corners. So let's see how we do that. So as it's mentioned here, this is just for debugging, and it really looks cool, and we just do it for that. So actually you could even do this without this step. You don't actually need it. But let's see how we do it. What we do here is we want to find all the contours. So the OpenCV has a method that can do that. All you have to do is provide an array in which you want to save them, and you want to provide the image on which you are doing it. In our case, we are doing it on the processed image, and we also when we find it, we want to find the biggest one. So the biggest one in our case will definitely be the outer one. So you can see that we are looking at the external ones, and then we use in our utils class, we get the biggest polygon index. So let's jump to this one and see how we do it. So we have all of our contours, and the contour area, there is a method which you can get, and it's just a value. And basically we're just looping through all of them and looking for the biggest one. So we assume that we are interested in the index, and we assume the value is 0, and that's the first one. And then if the whatever was on the index 0 is bigger than 0, that's our max value. Then we go to index 1, and if that's bigger, then that's max, and so on. It's really plain Java, nothing special except this one where we're getting the contour area. So we're just looking at what's the value of the area, how big. The bigger the area, the bigger the value, which means that our max value will increase, meaning that max value index will increase. At the end, we'll end up with the biggest one. When we have the biggest one, we want to mark it. Basically, we want to say, yeah, draw this green outline. And you can just do that. So you provide all of them, and you provide the index of the one that you want to mark. And you also provide the image on which you want to do it. And I do it on here it says it's original image. It's basically this one, debugging one, which we loaded. So if we take a look at this, it's just draw contours. And in the draw contours, you are providing the image, you're providing the contours, and you're providing the index of one that you want to draw. If it's negative, then all of them will be drawn. And here you can provide a color and the thickness. With that being done, you also want to find the points. Well, the points are again taken from the contours, so from the biggest one. And we have the util method to get them. So the getting of the points is a bit complicated, so to say. Again, we are doing this just for debugging. It's not really important at this point. So if you're not interested, you can just skip it. But I'll explain it. So we get first this approximation polygon. So if we jump to it, it's basically trying to approximate it to a polygon. So you want to get this polygonal curve, and there is a method inside of the OpenCV, and you can give it the precision and approximately say what this curve is supposed to be. So you want to get it from these polygons, and the polygon in our case here is just this the big outline. So it will be like this big square, and you want to make it a polygon out of this. So it will approximate it, so it's easier for us. And then you also have an array of assorted points, and the sorted points at this moment are just empty. But if this polygon size is not 4, so if it's not 1 by 4, then that means it's not really a polygon, and we want to abort immediately here. So it's not good. And in our case that will not happen, so it will be good and it will be a polygon. And then we want to calculate its center. Again, there is a moments method inside of the OpenCV which can help us with that, and it calculates the point, so the center x and center epsilon. And with that, and with our polygon that we have here, we basically go through the points that are here present, and we try to find our corners and also sort them. Sorting is important because there is no guarantee that they will always be returned in the same order, so you want to make sure that they do, and you want to make sure that they are sorted. So the corners I'm talking about are these ones here, so this one, this one, this one, and this one. And you want to make sure that you have them in the correct order always. Once we have gotten our points, we are drawing the markers. So the drawing of the markers is just, we want some marker size 30 with this thickness and type. You can change how the marker looks, you can change its color, and you can provide it in a point. And with that, we are just drawing it so that we know where the corners are. But the next important thing, a really important thing, is this removing of the lines. So let's take a look at what happens here. If you take a look at the image, this is our processed image currently, and this is after we have removed the lines. So let's see how we can do that. So again, OpenCV helps us a lot. We have a method that can detect the lines. And once we have done that, we have saved them here in these lines, and we'll just iterate through the pixels on this, and we basically draw them black. At this moment, you can probably see our background is black, meaning that if we draw the lines also black, they will be removed. And that works. So we detect them with this method, then we iterate through them, and then we just use this method to draw a black line on the exact point where the white line is. So basically we just delete it, so to say. And once the lines are removed, we move to the fun part. Now we want to cut out the image. We want to detect the cells. We want to figure out if there is something in the cell or if it's just black, so it's empty. And if there is something, we want to save that to this digits folder. So the first thing what we do is we create an empty matrix 9 by 9, and we also provide the processed image, and we provide our trained network, which is used later on. So our matrix is what we are going to be returning at the end. And now we want to calculate the cell width and the cell height. Basically, that's just the width of the processed image. So this one, in this case, this one here, divided by 9, because there are 9 rows and 9 cells. 9 rows and then 9 columns. And once we have the cell width and cell height, we create the cell size object with those values. Then we make a double loop, so we iterate through the rows and through the columns, and we always calculate the temp position. So meaning that at the first iteration we are going to be, if I open it, we're going to be here. Then the next iteration we're going to be somewhere around here, then here, and so on. So 9 times and then 9 times. And meaning that we want to iterate through all of them and detect the cells. So we take the processed image, and then we take this rectangle, and basically we say this is a point and this is the cell size, and we want to cut it out. We basically just clone it, we create a cell, and then we use the count non-zero method, which basically counts the pixels, and it tells you how many of them are empty and how many are not empty. And if the count is less than 150, so 150 is just some value I put in, you can put whatever you want. You can actually, if you print it out, you can see that there are a lot of bigger values here. So if it's less than 150, you can make sure that it's empty, definitely. And then what we do is just at this point in the matrix, we add 0 because we know that there is nothing there. Here I actually had something else which we do not need, so I'm just going to be removing it for now. And let's take a look at what we have here. So let me just do this. And here we want to save the image, which is the cell. So this is this here. So we are saving that part. And you can see that we are always just picking up the wherever the digit is. So this is in the else part. So if it's the count is bigger than 150, we definitely know that there is something there. So we just save that cell. And of course, here we are using our train network. If it's set to evaluate the image, we'll be taking a look at this one later on. And this will give us a value. It will say whatever it is, and we'll add it to the matrix, to this row and column. And if we go back, Sudoku matrix, then we use the util class to solve it, and we print it out. So here you can see that we printed it out. So this is the solved matrix. And then we also use this to print the solution to the image. So we have the processed image, which at this point is this. We also have the debugging image. So this, but just without the solution. So without the red numbers. And we have the Sudoku matrix. So it's the solved one at this point. And basically what we do is we create a processed image again. So it will be something like this one here. And then again, we detect the contours, same as before. And we again find the biggest one. We could actually move this to a util class so that we don't have the duplicated code. We again find all of the points. We find the cell width again, but this time from the old processed image, not from this one, because this one is being taken from the debugging image. So it means that it will be a bit bigger, so you can't really calculate it, because in this case the image, the original image, doesn't really have anything beyond this, but you could have some empty space above and from the sides and stuff like that. So you take the shrinked one, so the cropped one, which is this old processed image, and cell height, cell width, cell size, same as before. And then what we want to calculate is this offset, so basically this empty part, which is from the points gotten from the this one here. So this one, debugging image, from the points we remove this width and height from the old processed image. So this is just some offset, and then whenever we're calculating the temp position, we're just appending it here. And which means that if you would have some empty space, so if I would edit this with paint, and if I would have some empty space like here, we would basically append this. So this is offset. We would say instead of being somewhere here, we would say yeah, there is this offset, so I would be here at this point or here at this point, and then I know where I can print this image or on this digit. Otherwise it will maybe be printed here, and this is something we would not want. But in our case it's actually quite easy because this image doesn't have anything, so it just works. Yeah, but with that we do exactly the same things as before. We just count the zeros and we find the empty spaces, and now in the empty space we just put, so we are using the debugging image, and we just put the solved matrix, whatever it had at this point, we're just putting it in. And these are these red numbers, so we're just putting the solved values inside, so you can see them here. Nothing special, but yeah, that's it. So once we have solved that, and once we have printed it, or we printed the solution, we're done. It's actually quite simple. All the important things are the processing of the image. You have to make sure that this is correctly done. What I have also done here is I trained my network only on these two images. So if I would use some different image, it might not work. But this is just to save some time, because yeah, you need a big data set, and the one that I used is not that big. I think I have, if we take a look here, yeah, I have 204 files, which means that I have 204 different digits here, which I use to train, which is not much. You need maybe 100K or something like that to train it on really so that you can solve all of the images, so that you have different things, because you could have different fonts on different Sudoku puzzles and stuff like that. You want to be careful with that. Also, if you're using different images, you have to make sure that the lines are cut correctly, so you have to play with the values and stuff like that. But besides that, should be relatively simple. I guess that would be everything for this video. If you have any questions or if something is unclear, please just write me in the comments and I will try to explain them to you. And in the next one, we're going to take a look at how we can train a model and how we can save it, how we can load it, and how we can actually evaluate whatever is in this cell and try to figure out what the value behind the image is. So if you like this video, please do like it, and please do subscribe to my channel for more interesting videos to come. And I will see you in the next one.